Welcome to Pause Button Math. In this video, we'll learn the basics of scientific notation. It's important that you have paper and pencil so that you can actually do the problems along with me, rather than just watch the video. You also need to know the basics of exponents. For example, something raised to a power means to multiply that thing by itself multiple times. Scientific notation is used to represent very large numbers. For example, Saturn weighs 570 septillion kilograms, or very small numbers, such as the weight of a mosquito. The mass of a mosquito is less than 2 milligrams. The format of scientific notation is very specific. First, you have a coefficient, which is between 1 but less than 10, multiplied by a base, which is 10, and that base is raised to an integer exponent. Some examples of scientific notation are 6.21 times 10 to the 8th. This is good because we have a number between 1 less than 10. The exponent is an integer. The second one is also good. There is no decimal point in this problem, but that's okay. We just need a coefficient that is between 1 and less than 10. How about the next one? Is this scientific notation? No. 0.7 is not between 1 and less than 10. And lastly, this is also not a good example. 41.8 is greater than 10. Now let's have you try some. On your paper, please write the letters of the problems that are in correct scientific notation. Please click pause now, and we'll come back and show the answers in a few moments. Please click pause. Okay, here are the answers. How did you do? In problem B, 42 is bigger than 10. Letter E, 70.1 is bigger than 10. And in F and H, we have small decimal numbers that are smaller than 1. That means that only problems A, C, D, and G were in scientific notation. Let's review some rules of exponents. Remember that when you raise something to a power, you multiply it by itself. 10 squared is 10 times 10, which is 100. Larger powers of 10 means you multiply by 10 by itself more times. You end up with a much larger number. 10 to the 5th ends up being 100,000. So the rule is 10 to a positive number gives you a very large number. The opposite is true with negative exponents. Raising something to a negative power means take the reciprocal. This would be 1 over 10 squared, or 1 over 100, which equals a small decimal. If you raise it to progressively more negative numbers, such as -4, you get smaller and smaller decimals. 1 over 10 to the 4th is 1 over 10,000, or 0.0001. This is a very, very small number. So the rule here is 10 to the negative number is a small decimal. So let's take a look at these numbers and identify whether they represent large or small numbers. This one is small. The second one is large. The next one is a small number. Now let's take a second look at this fourth problem. Some students think that because it says 1.875, which is a fairly small number, might be a small number overall. But this 10 to the 8th tells the whole story. 10 to the 8th is a very large number. To finish our lesson, we're going to have you practice some problems on your paper. So number your paper 1 through 5. There is no need to copy these problems. You'll just write answers next to each one. You're going to identify yes or no if it is in scientific notation, and you're going to write small or large depending on if it's a large or small number. The example, we have a small number, but it is not technically in scientific notation because 0.23 is less than 1. So please click pause and try these problems on your own paper. Please click pause now. Okay, here are the answers. In future videos, we'll show you how to write numbers in scientific notation, and we'll actually do some multiplication and division with scientific notation. See you then.